Okay, great. We're so pleased to have our next expert lecture here. Jia Xu is here with us. And as you know, we're so proud to have our sponsors and our partners, including Boeing, NASA, RTX, and several others who are supporting the competition, along with 30 organizational partners from around the world. And they are continuing to support us at conferences and as well as supporting our teams with various resources. So Jia is the CEO of SkyGrid, a Boeing company focused on enabling autonomous flight. He brings extensive experience in strategic, technical, product, and market leadership to SkyGrid. Prior to joining SkyGrid, he served as the Chief Technology Officer for unmanned aerial systems and urban air mobility at Honeywell Aerospace, as well as Chief Architect for advanced air mobility systems at Airbus. Additionally, Jia has led UAS design efforts at General Atomics. He received his Ph.D. in aeronautics and astronautics from Stanford. Thank you so much for being here. We're so excited to hear your lecture today.
Thank you. Thank you for that really kind introduction there, and thanks for the audience that's coming to hear about this today. So let me share my screen here. Okay, so my name is Jia. Very excited to be able to talk to everybody a little bit about. I know you guys are all working on the airplane. I came from the airplane background, but I'm still very excited to talk to you about not so much the design and development of the autonomous aircraft itself, but something that's very important as soon as you want to put these vehicles into operation, which is how do you integrate them into the airspace, and what then does the integration of autonomous aircraft imply for the airspace of the future. So everybody here is probably, again, very familiar with what you see on the left column here. What's all of the innovation that we're bringing about in advanced aviation in terms of vehicle technology. So everything from certified electric powertrain and energetics to fly-by-wire, at much lower cost point and high performance than previously thought possible. Expanded automation for your autopilot and your mission layers that I think you're all building for the competition. And then for uncrewed aircraft, right? Unique aspects, things like very high availability avionics and autonomy systems, low cost sensors, and all of these things. So that's all great. But I think it's also important to point out that on the airspace side, which is how these aircraft will operate, how will they fly in a way that doesn't interfere with other existing aircraft that's already in operations, and how do they meet the compliance requirements? How do they meet the rules? There's also a lot of innovation. So things like how do we cover the low altitude airspace in terms of providing a digital twin of that operating environment? How do we get that data? How do we get higher resolution data to enable operations in urban environments for AAM, for example? How do we build services, maybe even cloud-based services that provide this information and provide decision support and other functionalities that are not part of the aircraft, but can support many aircraft in operation? So what we call approved third-party services. That's an important area. It's something that is close to SkyGrid's heart because we're ultimately a third-party service provider in the US. And it's also something that the FAA is thinking very seriously about in the US on how they should regulate, and then internationally within the U-Space construct in Europe and elsewhere in the world, folks are really thinking very hard about how do you approve these kind of services for more safety of life applications. And then behind that, right, how do we use cloud provision for those services? How do we expand the coverage, as I mentioned earlier, at low altitude for our CNS? That's the communication, navigation, and surveillance infrastructure. And then on top of that, today we have VFR, we have IFR, we have these flight rules that define how aircraft operate in different types of airspaces, what their behavior is, what is their expected level of service from ground infrastructure. There's been a lot of work, and folks are thinking about what does this, now that we have more automated aircraft, do we also need to automate elements of those service provisions in the airspace to enable these aircraft to operate more dynamically in a more automated way to fully take advantage of that autonomy? And so in a way, by having autonomy on the aircraft, we're also motivating potential automation in the air traffic management system to really close that loop and gain all of the benefits of more digital and automated flight. And for the uncrewed side of things are really important, like ground-based traffic surveillance, so that you know where everybody is, and that could be cooperative and non-cooperative. Non-cooperative is important because we want to make sure that we have full conspicuity of where all the aircrafts are, especially if you're operating autonomous aircraft with nobody on board. And then communication infrastructure for remote operations, which has, I think, from a day-to-day basis, you guys all pretty much realize in this competition is very important. So where SkyGrid is we don't really work on the left so much. We clearly interface with companies that work in that space, but we work on the right, provision for this autonomous future on the infrastructure and digital side. So where SkyGrid sits is we're a Boeing company. As mentioned earlier, we are actually part of Wisk now. We're a subsidiary of the Wisk company. Wisk is, of course, a significant bet by Boeing on autonomous AAM. It's meant to be a fully automated, self-flying urban air mobility vehicle from the get-go. So that's unique in this space. And it's a really good relationship in that we can work very closely with them because they will need a lot of these new technologies and capabilities to be able to operate at scale. And then, when they have that capability of automation, they can really unleash, I think, the potentials of this space. Having said that, SkyGrid is an entity that is focused on enabling the industry. So in addition to working with Wisk, we also work with other customers. We work with ANSPs, where some of these services have to go through. And our goal here is to really drive, as mentioned earlier, drive the adoption of autonomy and make this a viable business going forward. So whatever you guys are building, we want to make sure in a future day that that kind of follow-on vehicles of those types can effectively operate in the airspace. What does a problem space look like? So, these are, I think, some of the categories on the left you see of aircraft that folks are building in startup and large industrial environments. Higher assurance SUAS or larger SUAS or UAS. So in the US, we're coming to very close to the release of the draft Part 108 regulation, which is going to talk about how do we allow for pervasive beyond visual line of sight operations, whether that's for delivery or inspection, and potentially using quite large UAVs. This type of aircraft are going to need low altitude DAA, detect and avoid capabilities, maybe even off-boarded DAA, but they'll certainly need traffic information, potentially if they want to operate in more integrated airspace. And if they're larger aircraft, they may need that DAA and real-time traffic data in any case to reduce the air risks, depending on where they're operating. UTM and ATM integration is also an important topic there because you still need to ascend and get out of this very low altitude space, which may be shared with drones, even if the drones are segregated at lower altitudes. And then, of course, we have folks building uncrewed conventional takeoff aircraft that are serving middle mile cargo missions. And in those cases, you do need more machine readable data. You may need better digital ATC coordination mechanisms that doesn't just use voice. And weather data and traffic data are still going to be important for you to fully integrate and not impose any hazards or issues on existing operations, and being able to plan safely and efficiently, knowing that there may be weather coming in. And again, this is important because you no longer have a pilot on board who can see a cloud column or who can see the rain squall directly. So your situational awareness is somewhat impaired, and it's going to be dependent on machine provisioning of that data somehow for the remote operations center or the ground control station. So you can think of the gap there. A lot of these gaps are related to this impaired situational awareness for not having a pilot on board. And then the crewed and uncrewed eVTOL sections, which is obviously drawing a lot of interest. The issues here is really about how do we get safe, energy efficient operations. So how do I ensure that my strategic and tactical planning of the operations, and strategic being very important here, is accounting for all of the constraints and limitations of my own vehicle and what's happening in the space, so that I can charge safe, efficient, and also reliable service to the customer, right? So I can get there, I have my energy reserves, and then I can make sure that I get the customer there in the predicted time. So that predictability is very important. And it's also necessary in many cases to share the operational intent so that as a network, I can wrangle out the efficiencies of not only my own fleet operating over a urban environment, but also how do I operate with other fleets, right, that are sharing that information. So within the US, we have the concept of provider of services for UAM or PSU. That is kind of this network management entity that is doing the strategic and tactical planning and then doing the coordination of intent sharing across multiple fleets of these vehicles. So SkyGrid is providing some of those PSU services. And then when you go to uncrewed aircraft, it's kind of a combination of the category 2 and 3 here, right? You have on the one hand, all of the scaled operation UAM type attributes that I need for network coordination, intent sharing, strategic and tactical planning. But then I also need higher integrity data to support autonomous operations, and then traffic surveillance and weather awareness and all of these things. How do I then construct this system such that I can get to IFR level precision with VFR level flexibility, which may require future flight rules and changes to how we operate today. So that's in a nutshell. When you talk to, I think, the CEO of a lot of these companies that are building into this space, this is one of the areas. They have many areas, but this is certainly one of the areas that's keeping folks up at night is how do I solve these integration problems after I've solved the aircraft and certification problems, or probably not after, concurrently with that, so that you can get into operations from day one and then scale that operation from day 100 and forward. So what does the SkyGrid solution look like? So this kind of a ConOps picture or OV1 picture gives a sense of all the things that we touch with our services and what we bring to the table. So we build the proved digital infrastructure to integrate with all the sensors from our partners to take in all the data and enable this efficient operation of AM and integration of these aircraft into the airspace. We then also, with this capability, help to enable the operations in the national airspace and the global airspace. And in doing this and adding automation, accelerate the development of ATM, right? The modernization of ATM, as well as the evolution of XTM, which is this vision for more automated ATM action and for integrating UTM, which is unmanned traffic management, with the ATM system. So as you can see, SkyGrid builds this assured backend, which can manifest as cloud, but also on-prem solutions that takes in data from things like weather sensors, surveillance sensors for traffic, and other sensors. We fuse this into a common operating picture, and then build decision support tools on top of it to allow strategic and dynamic deconfliction and planning for your advanced aero mobility vehicles. So we can either provide the data or the services, or a combination of both. I think it's instructive to also take a view of the stack from the software side. So upstream, you'll see in this figure, we take in the high fidelity and integrity data that could be weather, traffic, terrain, aerodrome, airspace. And then we create this common operating picture, which here is expressed in our GUI, although certainly that digital twin data can deliver value just as providing the necessary API calls for your ground stations as well. And here, we're giving the folks on the ground real-time traffic awareness. We're building standard compliance traffic processors in the backend that will allow, basically enable, per the necessary standards, the efficient and safe integration of uncrewed aircraft into the airspace. You're seeing some demonstrations of that. And here we're also seeing showing weather, and can also show obviously TFRs and other things that make it clear to the user what is the nature of the operating environment. And different than some other things, we're building a safety of life system that will eventually also enable us to plan in an automated way around these hazards. So not only are we showing this to the operator, but all of our backend services in terms of flight planning, flight plan validation services, et cetera, can use this data with the right pedigree to help you make safety of life decisions. And that level of automation will increase in time. So essentially what SkyGrid is doing in a nutshell here is uplifts and integrates data that's commensurate with increasingly autonomous operations, create this integrated common operating picture, and then delivering on the right some of the strategic and tactical decision support services that will enable fleet operators, remote operation centers, and ANSPs, and potentially vertiport managers. So that's the digital backend that we're building with some real cyber physical reach-ins into actual infrastructure. Okay. I won't dwell on this point, but this is just showing some of the services that we're building. So we start with the digital information services, all the data that is needed to enable increasingly autonomous operations that can feed the ground control station into strategic planning services. So if we receive a flight plan, we can validate it against all sorts of complex constraints so that as a business or as an operator, you don't have to think about, how do I bring in all of this useful information? How do I fuse this integrated picture of the airspace and operating environment? Entities like SkyGrid and other third-party service providers can do that work. There are also tools that we're building now that will allow us to figure out what is the optimal time to request for clearance for your aircraft when you need to consider all of these constraints in the airspace. That's very important for UAM vehicles because they need to deconflict. If they're flying IFR, they need to deconflict from other IFR traffic per IFR separation requirements, which kind of drives up the kind of planning that you have to do to make sure that you're accessing the airspace efficiently. You also, in this case, need to understand the availability of the vertipads and all of these things in an end-to-end sense, right? As you're launching this operation, and if I need to shift this operation by some minutes to enable me to operate efficiently, this kind of tool will give that view of the space and of the future state of the operating environment. And then as we get into this highly assured platform, it's going to enable us to do tactical functions. So ground-based traffic surveillance and detect and avoid, rerouting dynamically to hazards that's kind of appearing, and then flow management within high volume operating environments. So many of these functions, as you see earlier, directly address the questions that we talked about in the problem space of how do I enable the initial integration of AAM vehicles, be they crewed or autonomous, and then how do I scale their operations in time with better data and smarter functionalities. And some of this will inevitably, and this is a theme that's going to come up again, is that some of this will inform how ATM, right? Bigger ATM may evolve. You can imagine these functions when they go beyond just the advanced aero mobility or advanced aviation context, they could have implications for how we plan strategic and tactically at the air traffic management level. And with that whole space moving, there was a lot of momentum in the US with potential new investments, and also globally with us seeing ATM as an area really truly worthy of investment if we want to unleash the full potential of not only the growing, we call legacy aviation that's growing, but also this future aviation possibilities of integrated airspace with crewed and uncrewed operations. I think it's very easy to see that what we're building here as an industry, what we're evolving in the AAM sandbox will have implications for the bigger airspace as well. We're very intentional about the planning of these services. It's not just, hey, let's build this, that's very cool. It's certainly based on customer feedback, it's based on industry, it's based on concept of operations, and ultimately it's based on some of the goals that we've outlined on the bottom in these boxes, right? How do we provide situational awareness to support automated cooperative planning and operations? How do we enable uncrewed operations? How do we increase the operational efficiency of the AAM to the operators, and also reduce the workload of ATM such that we can actually fit AAM into their operations. So it's driven and it flows very clearly from these objectives. The next few slides, we just talk about a few of these services. They are, in some sense, conceptually easy to explain. So for flight plan validation, right? If we receive a standard compliant flight plan, the SkyGrid system will alert to the operator on different time horizons of, well, are there going to be conflicts with other traffic? Are there going to be conflicts with weather? Are we going to encounter hazards? Are we going to encounter performance limitations? This takes a lot of the guesswork out of how do I fit the aircraft into the operating environment. And over time, we'd expect this type of capability as the assurance level of the platform increases toward a more certified and approved case, you can do more to close that circuit, right? So initially you might be providing warnings. Over time, you're providing advisories and alerting, and eventually you might be able to even close the loop on the automation here as well to provide that updated redirected flight plan. And by the way, a lot of these systems are either in prototype form or in operations in trial modes with some of the operators, both existing and kind of AAM operations here. So we're very, very excited about the future of these capabilities and the potential collaborations that we can have with fleet operators. This is the function that's mentioned earlier. How do I know when I can best request for takeoff clearance and plan my operations in a more, I would say, somewhere between the tactical and strategic modes. Again, knowing all the constraints that's in the airspace. So this is going to be a very interesting function when we do the initial integration of AM vehicles in more like sort of busier, more complex metropolitan areas where you may have multiple airports, you may have a lot of IFR traffic coming in. How do we essentially synchronize that traffic and deconflict them in a much more strategic way? And crucially here, some of the goals we mentioned earlier, it's about increasing the operational efficiency, but also the reliability of the service. So how do I predict when departure is going to happen in such a way that we will ensure that the arrival time makes sense for the customers? Lastly, I'll talk very quickly about the ground-based traffic surveillance. The way that the integration paradigm for autonomous traffic is written, and ICAO is very clear about this. One of the tenets is we want to integrate autonomous aircraft, but not at the expense of any other aviation, right? So we have to make sure that they do not impose additional workload or safety. Certainly safety can never be compromised, right? They don't impose any kind of limitations or constraints or burden on existing aviation. And the biggest, I think, question there is how do you deal with traffic, other traffic? So it's true that many aircraft carry ADS-B transponders, but those kind of requirements are not universal globally. And in many cases, ADS-B installation, right? It's hard to validate that, right? There may be cases where you're grandfathered in, even in the United States, where you don't have to have a transponder or ADS-B. There are cases where you don't, you may not turn them on, or people may spoof or may even have installed them poorly, such that they're not reporting the right information. So when you're operating an autonomous aircraft, you have to reach this higher level of assurance, such that that you're remaining well clear of all the other traffic. And so that's where it's necessary to have both onboard surveillance that could be non-cooperative, as well as offboard surveillance that's non-cooperative and validated. So we are building that surveillance processing system and making it scalable to support different types of autonomous aircraft operations. And the goal, right, the kind of objective that we've outlined is we have to cover the low altitude airspace where there are coverage gaps in sensors today. For the reasons I've mentioned earlier, we have to include cooperative and non-cooperative traffic to be robust and globally applicable. And the system has to have like the performance characteristics, whether it's latency, system availability, and integrity to meet the necessary standards, and that's been adopted and to define this industry. Okay. So this is just an illustration of how the system would work. We would connect with sensors, and our processor would kind of fuse the picture in the airspace across multiple operating volumes, distribute this data such that the operator or even the NSP who might want that low altitude data is able to access it, and then support intelligent decision making about strategic and tactical deconfliction using this data. It will enable aircraft to operate essentially with more flexibility around the world. So that's a very short discussion of where SkyGrid comes from, what are we building at a high level. It's really everything starts with the data and then the high integrity data, the common operating environment, as well as then all of these value added advanced functions, some of which are in this, when you think about UAM, they're in this PSU bucket, some of it that's more in enabling airspace integration. But we actually see a lot of overlap, right? Because if you want to do, let's say, more dynamic and automated air traffic management of AAM vehicles in a busy airspace, and especially in the future, if these vehicles will be more automated and self-flying, you will surely need very high integrity data, whether that's of the terrain, of the environment, obstacle space, weather, or traffic data. So there's a lot of overlap between the category of data provisioning and then all of these services that we have to do as a PSU. So what I'm going to leave with a few thoughts with you. One is I know everybody's building the airplane. That's incredibly important. And within the context of the competition, it's definitely a must-have. But anytime when you want to build this outside to be able to operate, you have to think beyond the vehicle when it comes to autonomy. So what is the airspace construct that I'm operating under? What is my operational construct? What is my ConOps? What are then the digital and potentially physical system that's going to be needed both onboard and offboard to enable that operation? Also call out that we are, as a company, also very interested in emergency operations, since they are one of the avenues that I think AAM will come to fruition first. It's certainly a noble use case. So I'm really thankful that Go Aero is pushing in this direction. It's a really worthwhile path, and it also not only I think stresses the dynamism of the onboard technologies and your adaptability, but it also stresses at when you're actually operating the ATM problem, right? Because if you're fighting, let's say, forest fire, it's a very dynamic air traffic environment. You have lots of aircraft. You're going to have lots of drones in the future. You're going to have uncrewed aircraft doing all sorts of things. How you kind of integrate that airspace and operate efficiently and safely is again a noble pursuit and an important question to solve. So I'm really glad that you guys are motivating pieces of that problem. Already talked at length about data. I think the other thing that's really interesting is there's this relationship between getting more autonomy in the aircraft and having a more digital and potentially automated airspace. Those two things kind of go hand in hand, because as soon as you're more autonomous on the aircraft side, you're starting to see some of the challenges shift from, how do I operate the aircraft? How do I enable autonomy to how do I reduce perhaps the need for voice comm? How do I get a better digital picture of the airspace? How do I have more data-driven interactions with air traffic management? How can I better take into all of the strategic intent of the different players and actors in the space and come up with better solutions in terms of air traffic management and integration for everybody? So you both, I think, unlock the opportunities, and then perhaps in this whack-a-mole analogy, right? As you whack away the moles in terms of inefficiency for onboard operations when you're going autonomous and when you're unlocking value, then the next one is probably going to come from air traffic management and airspace. So there's both the near term, how do I integrate, and then how do I get in the long term into scaled operations with a more digital operating environment. And to get there, this term third-party services providers, entities like SkyGrid, I think we really have to figure out as an industry how to approve these services. What is the definition of good for strategic and tactical deconfliction of AAM vehicles and other aircraft operating at volume? We're starting to do some of that in the low altitude space in the UTM side. But of course, the safety metrics and requirements there are very, very different. So as well as the operating environment, right? We're not in a traditionally aviation space when you're below 400 feet in the US and elsewhere in the world. So as you come up into integrated airspace, how do we do that? How do we conform to the safety requirements? How do we understand that aviation-centric operating environment? That's something that I think third-party services needs to grow up into. And that's what we're trying to do here at SkyGrid. And finally, if it's not clear already, the opening slide we discussed, let's use AAM, right? It's a great opportunity. It's a societal, whether it's drones or air taxis or large autonomous aircraft. This is changing aviation, and it will change society. So let's use this opportunity and all the interest, the regulatory attention, the excitement to think about how do we innovate both on the vehicle side for all the obvious reasons and spaces that we talked about, but also how to innovate on the airspace and system side. I think the real opportunity, is in both of those buckets. And finally, really glad to have had this the chat, and love what you guys are doing at Go Aero. Really proud that Boeing is a sponsor and actively involved in the formulation of the goals. So go Aero.
Thanks, Todd, so much. Really appreciate all of the content and giving us a deep dive into SkyGrid and what you're up to. If there are folks that have questions, as usual, please use the Q&A function to post any questions that you might have or any comments that you would like to make at the moment. As a reminder, the lecture is being recorded and all the slides will be available on herox.com/goaero under the expert lectures section. So you're welcome to review the slides more in depth later. In the meantime, Jai, I wonder if you can, as you may know, right, many of our teams are rather nascent in their development, right? We are currently in stage 2 of the competition, where teams by the end of September are being asked to develop a subscale prototype of their emergency response vehicles.
Mhm.
And obviously, you know that we are encouraging all teams to be autonomy enabled. Considering where they are in terms of sort of their prototype phase, really sort of taking paper concepts and bringing them to fruition, can you speak a little bit more or perhaps provide some advice in terms of how they should think about autonomy enabled? What should that include? What are sort of the key elements that they should make sure that are integrated into their systems as they develop a prototype so that they have a good foundation as they're building over the next 2 years to their full-size flyers?
Mm. Good question. So, I think there are different perspectives here. I would say that taking an incremental approach makes a lot of sense. Making sure your modeling and simulation environment is going to enable you to do a lot of these testing and development at speed. Not just rely on purely flight tests, although flight tests are certainly very, very important, but having the framework to do some of that at scale, some of that exploration and development in a very controlled way, in a simulated way, I think is going to be important. I don't know what the kind of budget consideration is, but there's obviously a trade-off between the quality of your sensors and the level of autonomy that you can achieve, and then what you can do kind of in post-processing and in the algorithm side to do the right thing. But certainly having good sensors and awareness of the environment is going to be very important. So again, it depends on, I think, the nature of the kind of like the mission that you have to accomplish. And I took a very quick look at some of those things. So those would be some of the things that kind of top to mind for me.
Mm. Yeah. I wonder also if just sort of more generally, you can speak to the resources. For example, I'm not sure that teams are necessarily, as you're sort of the air traffic management, really sort of how do you integrate into systems since teams are so focused on the flyers themselves? Are there resources, are there places that teams should be looking in order to sort of understand these systems more holistically so that as they build, they understand the integration factors and what they should consider, how they should consider, and how they
Right.
make sure they fit within these larger systems?
Yeah, that's a really good question. I mean, I think there are probably two answers, right? The more narrow question, the answer is probably that you're nicely insulated from presumably some of these problems as you're running these in very, in controlled environments in airspace that you have essentially blocked off for these tests, right? So I don't think they need to be overly concerned with some of those questions. I don't know to what extent you guys need to be concerned with flight termination systems and those kind of things. If that's part of the scope of the competition, or if it's assumed that you'll be able to close all of those safety case and safety of flight considerations without them.
Mm-hmm.
But insofar as airspace integration that's a longer term, right? If you want to make this a business, if you're, let's say, developing this now, but then your ultimate goal for the team and is to go do a company, or you already have a company, and you want to do, let's say, cargo delivery, or you want to do long range inspection, or you actually want to fly, you want to rescue someone, right? As the goal of one of the, the project is to be able to rescue them from a dangerous environment. And then you'll have to consider some of these dimensions of the problem, like how do I, do I want to integrate as a large drone, maybe under future Part 108 in the US, or EU space constructs, or do I need to be operating in IFR mode in integrated airspace, depending on what the mission needs, right? The altitude that you need, the airspace that you need access, and then you could take, you may take down very different, walk down very different path in terms of integration into that environment, with attendant implications for your onboard equipage and your offboard infrastructure. In terms of where to get this information, one, it's not quite self-serving. I think we do a decent job of highlighting some of these issues. If you scan the barcode here, and you can follow up with the link, our concept of operation does go into more depth on the motivations of some of our services and how airspace integration for AAM, like some of the salient issues and how you might be able to do it. And there are also some references, and I would just point out for things like UAM integration, obviously the FAA ConOps for UAM is a good reference where they talk about their vision for airspace integration initially and then at scale for these AAM vehicles. The FAA's more recent UTM implementation plan is also a good primer on the progress of some of the work that's been done on the smaller UAS side, right? If your intent is to go on more of the low altitude UAS route. The EU, of course, EASA has their ConOps for UTM and USpace. The EASA view of USpace is more comprehensive, right? It starts today as more low altitude, but they have a vision for expanding USpace into higher altitude operations with different levels of assurance requirements and different levels of equipage requirements. And so that's also a good view of, again, what are some of the salient issues? What are it even goes into like the service and architectures that one might need to do some of these things. And of course, if you have access to the information, the ICAO has a really good RPAS integration document that talks about the requirements in terms of communication, surveillance, and all of these things. That's very good. So I think that's also referenced in our document. That'll give you a first view, and then if you want to get more details, you can probably pay for the RTCA standards that would go into like specifically what kind of radar would you have, what is the requirements for communication systems if you want to integrate a autonomous aircraft into the airspace today under instrument flight procedures.
Very, very helpful. A lot of information there. So
Yeah.
I hope the teams can come back and review your comments here in terms of all of the resources that you've provided. And if you wouldn't mind, we'll follow up with you afterwards, perhaps, and just make a quick list so that we can share that with the teams. And the QR code, very helpful. We'll also make sure and share that with the teams as well. And if there are opportunities that you find that SkyGrid would like to work with our teams, please let us know. And if the teams are interested as well, let us continue to find ways for collaboration, in the industry.
Excellent.
So, Jia, thank you so much for your time. Very much appreciated. We appreciate all of the information you've offered. And to the teams, we look forward to your continued participation. As a reminder, the Stage 2 deadline is coming in September. If you haven't had an opportunity yet to begin your Stage 2 registration documents, please take the opportunity to review the agreements and let us know if you have any questions. We are always here to help or schedule a conversation with you. Thank you so much, Jia. We really appreciate your time.
Thank you. Thanks everyone for tuning in.
Bye-bye.